Solving linear systems by linear combination, also known as elimination. So far, we have learned two ways to solve linear systems. The first way that we have talked about is graphing. Remember, to solve a linear system by graphing, we want to see where the two lines intersect, and that ordered pair is the solution to the linear system. We have also learned how to use substitution, and that's where we find the value to one variable and substitute it into the other equation to solve for the unknown variable. All right, let's go ahead and practice this new method called elimination. Let's look at example number 1. Here, our linear system is 4x plus 3y equals 16 and 2x minus 3y equals 8. In step 1, you want to make sure that your x terms, so 4x and 2x, are lined up. You want to make sure that your y terms are lined up. You want to make sure that your equals is lined up. And you want to make sure that your constant terms, remember those are numbers without variables, are also lined up. Once you do that, you can move on to the next step. So in this case, we didn't have to do anything for step 1. All right, step 2. It says make sure that there is a variable that cancels. That means that we want to have opposite coefficients. Remember that opposite coefficients means, for example, -2 and +2. Those are opposites. Coefficient means the number in front of the variable. So if we go ahead and take a look, and I'm going to erase this, take a look at our system, you can see that in our y terms, they have opposite coefficients. Our y terms have a +3 and a -3. Again, those are opposite coefficients. Sometimes they won't be given to you like that, and if they're not, we have to create opposite coefficients. So in this problem, we have finished step 1, finished step 2, so now we can go ahead and move down to step 3. So once the equations are lined up and once there are opposites, we can go ahead and combine the two equations. So the first equation is 4x plus 3y equals 16, and the bottom equation is 2x minus 3y equals 8. Right, now the reason that we call this linear combination is because we are combining the two equations. 4x plus 2x is 6x. Now, the reason we can also call this method elimination is because the idea here when you have the opposite coefficients is that when you combine them, they eliminate each other, they go away. So then all you are left with is equals 24. And now we just have a one-step equation that we can solve for. Divide both sides by 6, and we get that x equals 4. So that's pretty basic. All right, let's go down and see what's the next step. Now it says plug your answer into an original equation to solve for the other variable. All right, so we have x. We know x equals 4, which means we have to solve for y. In this method, it doesn't matter which equation you start with. I'm going to choose 4x plus 3y equals 16. So 4x plus 3y equals 16. And since I know that x is 4, I'm going to go ahead and take the 4 and plug it in where x is. So we get 4 times 4 plus 3y equals 16. And we're going to solve this. 4 times 4 is 16 plus 3y equals 16. Subtract 16 from both sides of our equation. And 3y equals 0. Divide both sides by 3, and we get that y equals 0. So now that we have x and y, we can write our solution. Remember, we always write a solution as an ordered pair, x, comma, y. So the solution to this system is 4, 0. All right, let's go ahead and continue on to the next example. In this next example, our system is 2x plus y equals 4 and x minus y equals 2. Before I move on, I'm just going to actually clear the screen so that it doesn't get so confusing. All right, so we're on problem 2. 2x plus y equals 4 and x minus y equals 2. All right, in step 1, we want to make sure our variable terms are all lined up, our equals is lined up, and our constant terms are lined up. So very quickly, I should see my x terms, my y terms, my equals, and my constant terms are all lined up. In this case, they are. So we don't need to do anything in step 1, so now we can move on to step 2. All right, in step 2, we want to make sure that there are opposite coefficients. Notice that our y terms have opposites. One of our equations has a positive 1, and the other equation has a negative 1. Those are opposite coefficients. So we don't need to do anything in step 2. So now we move on to step 3. In step 3, we're going to combine the two equations, which means add them. So we have 2x plus y equals 4 and x minus y equals 2. If I'm combining the two equations, remember that 2x plus x is 3x, but the reason we combine and make sure we have opposite coefficients is so that one variable is eliminated. So 2x plus x is 3x equals 4 plus 2, which is 6. The last thing that we need to do here is divide both sides by 3, and we get that x equals 2. All right, now that we know what x is, we have to find y. So I'm going to take one of the first equations, in this case x minus y equals 2, and I'm going to go ahead and take 2 and plug it in where x is. So now we have 2 minus y equals 2. Subtract 2 from both sides, and we get negative y equals 0. We can divide both sides by negative 1, and we would also get y equals 0. So now that we know what x and y is, we can write our solution. And the solution to this system, I went a little too far. All right, the solution is 2, 0, and that is our ordered pair. All right, let's go ahead and do some more practice. All right, example number 3. So first thing that we always want to do when we look at our system is make sure that our terms are lined up. Notice right away in this example, they're not. So we want to make one of the equations look like the other, and it really doesn't matter which one you pick. I'm going to choose to make both equations have the x term and the y term on the left of my equals and the constant on the right of my equals. So in order to do that, I need to, in my other equation, add 5x to both sides. Now by doing that, I get my x term and my y term on the left. Notice in the first equation, x is first and y is second. When I write this equation, I want to make sure that I write x first. So I get 5x, since 2y is positive, I put plus 2y, and then we're left with equals 12. So now, if I look at my two equations, 5x plus 2y equals 12, and 3x plus 2y equals 8, you will see that they are lined up. Our x terms, our y terms, and our constants. Okay, so that's step 1. Now we can move on to step 2. Step 2 says we have to have opposite coefficients. Well, notice that my x terms, 5 and 3, those aren't opposite coefficients. And my y terms, well, they're both a positive 2. That we can easily make one of those a negative 2 so that they are opposite by multiplying by a negative 1. So we're going to take one of the equations and multiply the entire equation by negative 1. So if I do that, we get negative 3x minus 2y equals 8. Oops, negative 8. And then the top equation, which didn't change, is 5x plus 2y, which equals 12. Now we can take our two equations and add them. So let me just rewrite them here. Negative 3x minus 2y equals negative 8, and 5x plus 2y equals 12. So in this problem, when we add, we are eliminating the y variable because those are the terms that have opposite coefficients. Negative 3x plus 5x is 2x. Negative 8 plus 12 is 4. Divide both sides by 2, and we get that x equals 2. All right, now that we know what x is, we need to find y. So we're going to take one of the original equations. I'm going to go ahead with 5x plus 2y equals 12, and I'm going to take x and plug it in. So we have 5 times 2 plus 2y equals 12. And let's scroll down just a little bit. 5 times 2 is 10 plus 2y equals 12. Subtract 10 from both sides of your equation and you get 2y equals 2. Divide both sides by 2 and we get that y is 1. So the solution to this linear system is 2, 1. Alright, nice job. Let's go ahead and move on to the next problem. Alright, number 4. Now before I move on, I'm just going to clear the board so that it doesn't get confusing. Alright, in number 4, again in step 1, we want to make sure our x terms are lined up, our y terms are lined up, our equals is lined up, and that our constants are lined up. In this case, they are, so we are done with step 1. Alright, in step 2, we need to make sure that there are opposite coefficients. Well, if I look at my x terms, 3 and negative 4, those aren't opposite. Then I look at my y terms, 5 and 2. Well, those aren't opposite. So, what can I do? Well, what we can do in a situation like this is we can take the equation 3x plus 5y equals 6, and the other equation, negative 4x plus 2y equals 5, and multiply them. If we choose to eliminate the variable x, I'm going to multiply the opposite equation by the coefficient in the other equation. So in the top equation, my coefficient for my x variable is negative 4. Now I'm going to choose to multiply the top equation just by 4. Then we're going to take the bottom equation and we're going to multiply it by the coefficient of the x variable in the top equation, which is 3. Now in this case, the reason I chose not to do a negative 4 is because we want these numbers to be opposites. That means one needs to be positive and one needs to be negative. Notice that if we distribute our 4, we're going to get a positive 12x. And down here, when we distribute the 3, we're going to get a negative 12x. And that would give us opposites. So you have to pay attention to what you're choosing to multiply by. So let's go ahead and multiply our two equations. The top equation is going to become 12x plus 20y equals 24. And the bottom equation will become negative 12x plus 6y equals 15. Alright, now that we have our terms lined up and we have opposite coefficients, we can combine the two equations. So I'm just going to continue with that down here. Remember that our x terms are the ones we chose to eliminate. So now we have 20 plus 6, which is 26y. And 24 plus 15 is 39. Divide both sides by 26. And when we do that, we get that y equals 3/2. Alright, now that we know what y is, we need to take one of the original equations and figure out what x is. So let me look one of the original equations. I'm going to do 3x plus 5y equals 6. So 3x plus 5y equals 6. And since I know y is 3/2, I'm going to plug it in. So we've got 3x plus 5 times 3/2 equals 6. Now I'm going to simplify this. 3x plus 15/2 equals 6. Subtract 15/2 from both sides of our equation. And when we do that, we get 3x equals, let me check with the calculator. Let's see, 6 minus 15/2, and we get negative 3/2. And then the last thing we want to do is divide both sides of our equation by 3. So negative 3/2 divided by 3 is negative 1/2. So the solution to this system x comma y is negative a half, 3/2. So negative 1/2 comma 3/2. All right, let's go ahead and do this last example, number 5. All right, let me go ahead and clear out our board. All right, now if I look at my terms, they are all lined up, but I don't have opposite coefficients. If I look at my y terms, I have a 5 and a 7, and if I look at my x terms, I have a -1 and a 2. Now, if I look at the top equation, I can multiply this term by 2, and then the x variable would have opposite coefficients. So that's what I'm going to do. I'm going to take the entire top equation and just multiply it by 2. When we do that, we're going to get negative 2x minus 10y equals 60. And with the bottom equation that didn't change, I now have opposite coefficients. And I just realized that I did step 2 in step 1's box, so that really goes there. Alright, so now we move on to step 3, where we're going to actually combine the two equations. So in step 3, we've got negative 2x minus 10y equals 60, and 2x minus 7y equals 25. So we're going to go ahead and add them. Our x variable terms cancel or eliminate each other. Negative 10 plus negative 7 is negative 17y. 60 plus 25 is 85. We're going to divide both sides by negative 17. And we get that y equals 9, I believe. Let's see, 85 divided by 17. Oh, it's 5. I was totally wrong. Negative 5. All right, so y equals negative 5. Now we need to figure out what x is by plugging our y value into one of the original equations. So let's go ahead. I'm going to use 2x minus 7y equals 25. And I'm going to take y and plug it in. So we have 2x minus 7 times negative 5 equals 25. 2x plus 35 equals 25. And now we're going to go ahead and subtract 35 from both sides of our equation. And we get 2x equals negative 10. Divide both sides by 2, and we get that x equals negative 5. So here we have our x and our y. Both happen to be negative 5. So we're going to have our solution negative 5, negative 5. All right, I think that is all of our examples. Yep, it is. So what you need to do now is go and ask Miss Stahl or Mrs. Wilkin for today's homework assignment, which is a worksheet.